Good evening, children.
Good evening, ma'am.
Good
Good
evening.
evening, ma'am.
Good evening, children. Good evening. Excuse me, children. So I had gone out. I was held up outside. I couldn't start today's meeting on time. I thought I'll start by 6:30, but I couldn't. It's now 6:40. I'm sorry about that. So today we are starting a new chapter, linear equations. We have some more important questions in polynomials. I haven't still, prepared the presentations. So once it's ready, we'll just get back to those questions on polynomials. So today I'm starting this chapter, linear equations. It's actually linear equation in one variable. In two variables. Please write down. Have you all started writing?
Yes, ma'am.
Yes.
Yeah.
Yes, ma'am.
I'll let you. Linear polynomial, sorry, it's not equation. I always, sorry, children, linear polynomial. Please write down. Done writing, children?
Completed, ma'am.
Completed, ma'am. Completed, ma'am.
I'll let you.
1 minute.
Yeah.
Completed, ma'am.
Yeah, very good. All right. So children, what do we see in this slide? So we see the first we see the standard form of a linear polynomial. We see the standard form of a linear polynomial in one variable x. And what is the standard form? Ax plus b. Ax plus b. Just take this example, 5x plus 3. 5x plus 3 is in the form ax plus b. This polynomial 5x plus 3 is in the form ax plus b. See, why do we say the standard form is ax plus b? Because the variable is x. The variable is x. The coefficient of x is called a. And the constant is called b. Like in this example. See the coefficient of x, 5. And the constant is 3. The constant is 3. Now you know that 5x plus 3 is an example of a linear polynomial in one variable x. So now that we have learned the chapter polynomials, I'm sure all of you can recognize this polynomial. This is the polynomial in one variable x, and the degree of this polynomial is 1. So it's a linear polynomial. 5x plus 3 is a polynomial. 5x plus 3 is a linear polynomial because the power of x is 1. So it's a linear polynomial. And there is only one variable x. There is only one variable x. So 5x plus 3 is a linear polynomial in one variable x. Now compare that with the standard form ax plus b. See here, the variable is x. The coefficient of x is a. So a is 5. In this example, a is 5. And the constant is b. And in this example, b is 3. See, if it is 5x minus 3, then b is minus 3. If the example is 5x minus 3, then b is minus 3. Now, the variable can be x, y, z, anything. Now, supposing we have an example like this, a polynomial like this. Supposing we have the polynomial, say 4z minus 7 by 5. So then you must write the standard form as az plus b, because z is the polynomial. Sorry, z is the variable. See, in general, we take x as the variable. In general, we take x as the variable. So we write the standard form in x, ax plus b. If z is the variable, if in your example, z is the variable, see this example, 4z minus 7 by 5. So the variable is z. Then don't compare it with the standard form ax plus b, because in ax plus b, x is the variable. This is 4z minus 7 by 5. So the variable is z. So the standard form will be az plus b. Az plus b. See, this is in one variable x. The variable can be y, the variable can be z. All right. So then for this example, you'll have to compare it with the standard form az plus b, where z is the variable. A is the coefficient of z and b is the constant. So when you compare, you get a is equal to 4 and b is equal to minus 7 by 5. B is equal to minus 7 by 5. Now, in this example, say root 9y minus 3 by 7. All right. So we know that this is a polynomial. We know that this is a polynomial because root 9, root 9 is absolutely fine. The variable is y and its power is 1. So it is a linear polynomial. The variable is y, its power is 1. And this expression is a linear polynomial in one variable y. In one variable y. So then the standard form you must say is ay plus b because the variable is y. So you say ay plus b. Ay plus b. Okay, so when you compare this example or this linear polynomial with the standard form ay plus b, you get a is equal to root 9. A is equal to root 9 and b is equal to minus 3 by 7. B is equal to minus 3 by 7. So it is not that it is ax plus b. Ax plus b in one variable x. If the variable is y, ay plus b. If the variable is p, it is ap plus b. So like that. So, but you have to give one version. So this is the standard form of a linear polynomial in one variable x. If the variable is x, then the standard form is ax plus b. Now, the most important condition is the coefficient of the variable x should not be 0. That is, a should not be 0. Who's a? A is the coefficient of x. Okay. So in this example, a is the coefficient of x. A is the coefficient of x. See here, ax plus b. A is the coefficient of x. A should not be 0. Because if this is 0, then that x term itself is gone. If it is 0x minus 5, then that means there is no x term. It's only minus 5. And minus 5 is not a linear polynomial. It's a constant polynomial. The coefficient of x, which is a, I'll tell you again. The coefficient of x, which is a, should not be 0. See here, the condition a should not be 0. Why a should not be 0? So supposing you have this polynomial 0x minus 7. All right. And we say that this is an example. This is an example of a linear polynomial. Let's analyze. So what is the coefficient of x? A is 0. A is 0. Now what happens when it's 0x? 0x means it's 0. That means this is not there at all. 0x is 0. So that means what we are left with minus 7. And what is minus 7? Minus 7 is a constant polynomial. It's not a linear polynomial. It's not a linear polynomial. So the coefficient of x should not be 0. The coefficient of x should not be 0. A can be the coefficient of x, which is a, can be any real number. Can be any real number, but it should not be 0. But b can be 0. Now see here, when I take this example 7x. 7x is a linear polynomial. 7x is a linear polynomial. Okay, now in 7x, it is 7x plus 0. So when you compare it with ax plus b, a is 7 and b is 0. B can be 0 because 7x is still a linear polynomial. 7x is still a linear polynomial. When b is 0, that is the constant is 0. So 7x plus 0 is still 7x, which is a linear polynomial in one variable x. The value of a is 7 and the value of b is 0. B can be 0. When b is 0, it's still a linear polynomial. The way you can see the variable x. You can see the variable x. Which means that is why these conditions. A and b are real numbers. A and b are real numbers. A and B can take any rational value or irrational value. But a should not be 0. A should not be 0. B can be anything. B can be 0. B can be any real value, including 0. But A can be any real value, but not 0. That's the condition. Because if A is 0, then if it is 0x, then there's no x term at all. You'll be left only with a constant. And that will be a constant polynomial and not a linear polynomial. So as I was telling you, so I'll just repeat that. So when we take this example, 0x minus, say, 3. This one is, here you see that the coefficient of x is 0. That is, it's like when you compare it with ax plus b, when you compare this with ax plus b, you get a is 0, and b is minus 3. Supposing we take this example, and you compare this one with the standard form ax plus b, you find that a is 0 and b is minus 3. Now, when it's 0x, it's nothing but 0. 0x is 0, so remove it. It has no meaning. It has no value. It's 0. Take it away. So there is only minus 3 there, which is not a linear polynomial, but a constant polynomial. That is why a should not be 0. A should not be 0. But b can be 0. B can be 0. A should not be 0. B can be 0. So if it is 5x, Now, when you compare this with ax plus b, now 5x we all know is a polynomial, is a linear polynomial in one variable x. And when you compare this with ax plus b, a is equal to 5. A is equal to 5. B, there is no b term, so it's like plus 0, 5x plus 0, because you want to get the value of b. So b is 0. That's still fine, because b is 0, 5x is a linear polynomial. That is not, that doesn't change. Because b is 0, 5x still remains a linear polynomial. That doesn't change because b is 0. So when you take this example 5x, it means 5x plus 0. When you take this example 5x, it is 5x plus 0. And when you compare this with ax plus b, we get a is equal to 5 and b is 0. But it's still fine. B can be 0. So that's what it is. The standard form of a linear polynomial, meaning degree 1, linear polynomial in one variable x. Only one variable should be there. Okay, x. The standard form is ax plus b, like 4x minus 5, ax plus b, 4x minus 5, like that. Where a and b, see, you don't have to say about x. X is the variable. So you'll have to talk about a and b. Who are a? X is the variable. We defined that already. X is the variable. Okay. Then who are a and b? A and b are real numbers. Okay. Who are a and b? A and b are real numbers. But a should not be 0. So they are the conditions. Ax plus b is the standard form. X is the variable. So we have explained what x is. X is the variable. Then what about a and b? A and b can be any real value, any real number. That means a and b can be rational or irrational. Again, the most important condition, a should not be 0. Now, coming to the next one, standard form of a linear polynomial in two variables x and y. Standard form of a linear polynomial, linear polynomial in two variables x and y is ax plus by plus c. Ax plus by plus c. See, you can see the two variables x and y. You can see the two variables x and y. So you have to explain about a, b, and c. Who are a, b, and c? Okay, x and y are the variables. We already mentioned them. Two variables x and y. So x and y are the two variables. Then what about a, b, and c? Who are they? A, b, c can be any real number. A, b, c can be any real number. But now you should be able to understand this easily. The coefficient of x, which is a, and the coefficient of y, which is b, should not be 0. Because if they are 0, then you will, if the coefficient of x is 0, then it is 0x. Then the variable x is gone. Then you will not have two variables. Again, if the coefficient of y, that is b, if b is 0, then 0y, that means y is not there. The y variable is gone. So there'll be only one variable x. But what is this? This is the standard form of a linear polynomial in two variables x and y. That means in the equation, you must, in the polynomial, you must have both the variables x and y. Only then it will be in two variables x and y. The polynomial must have both the variables. There should be x, there should be y also. Then only it will be linear polynomial in two variables x and y. Which means the coefficient of x, which is a, should not be 0. The coefficient of y, which is b, should not be 0. C can be anything. C can be 0. C can be any real value. So the condition is a, b, and c are real numbers. But a and b should not be 0. Because if they are 0, if a is 0, x is gone. If b is 0, y is gone. But we need both x and y. Only then you can say it is linear in x and y. I hope all of you understand. So you should explain the the different parts of the polynomial. So as I told you, we already mentioned that it is the standard form of a linear polynomial. See here, We said it's a standard form of a linear polynomial in two variables, x and y. So all of us understand that x and y are the two variables. So then you should talk about a, b, and c. Who are they? They are real numbers. A, b, c are real numbers. The condition a and b should not be 0. Because you said a, b, c can be real numbers. Real numbers means they can be 0. No, but a and b should not be 0. Because we want both x and y in the polynomial. So that means their coefficients a and b should not be 0. So ax plus by plus c is the standard form of a linear polynomial in two variables, x and y. A, b, c can be any real value, but a and b should not be 0. Now let's take an example. Now tell me the values of a, b, and c, children. In this example, tell me the values of a, b, and c. Yeah, tell me the values of a, b, and c.
Ma'am, A is root 2 and B is minus 1 by 3 and C is minus 5.
Correct. So this is nothing but root 2x minus 1 by 3y minus 5. Minus 5. So when you compare this with ax plus by plus c, see the standard form is ax plus by plus c. You must not take minus signs because in the example we have minus. The standard form is ax plus by plus c. Now compare. A is root 2. B is equal to minus 1 by 3 and c is equal to minus 5. The coefficient of x is a, root 2. The coefficient of y is b, minus 1 by 3. And the constant is c, minus 5. All of us get that?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very good. So now in root 3y minus or okay plus x, what are the values of a, b, and c? Now,
Ma'am, A is 1, B is root 3, and C is 0, ma'am.
c is 0. Correct. Because this is nothing but x plus root 3y. Now x plus root 3y is a linear polynomial. It is linear because see the power of x 1, the power of y 1. So it is linear. It is linear. It is a linear polynomial in two variables, x and y. It is a linear polynomial in two variables, x and y. When you compare it with ax, when you compare this with ax plus by plus c, we get a is equal to 1. A is equal to 1 because there's nothing in front of x. That means 1. A is equal to 1. B is equal to root 3. B is equal to root 3. And c, there is no c term at all. Let me write it here. 1 minute. When you compare this with ax plus by plus c, here there is no c term, so it's like plus 0. So a is equal to 1. A is equal to 1. There is 1. It's x meaning 1x. B is equal to root 3. And c is equal to 0. C can be 0. A and B should not be 0. So now we'll define the standard form of a linear equation in one variable x and a linear equation in two variables x and y. Please write down, children. Please listen to this, children. Now, in this example, 5x minus 3. This is a linear polynomial in one variable x. When you equate it to 0, it is called a linear equation in one variable x. When you equate a linear polynomial to 0, it's called a linear equation. When you equate a linear polynomial to 0, when you say a linear polynomial is equal to 0, when you equate it to 0, it is called a linear equation in one variable x or two variables x and y depending. So here, if I take the polynomial 5x minus 3, okay, so 5x minus 3. Now, when you take 5x, don't write this, 5x minus 3. This one is a linear polynomial in one variable x. When you equate it to 0, it is called a linear equation in one variable x. Similarly, in this example, if I say 3x minus 7y plus 2. Now, 3x minus 7y plus 2 is a linear polynomial in two variables, x and y. It's a linear polynomial in two variables, x and y. When you equate this to 0, it is called a linear equation. Polynomial becomes equation now. Linear polynomial becomes linear equation. A linear equation in two variables, x and y. The conditions remain the same. A, B, C real numbers, A not equal to 0, B not equal to 0. The conditions remain. That's all it is. Right on, children? See, that's what you see. The standard form is equated to 0. The standard form is equated to 0. Then it's called a linear equation. When a linear polynomial is equated to 0, it's called a linear equation. Please write, children.
Completed, ma'am.
Completed, ma'am. Completed, ma'am.
Completed, ma'am.
Completed, ma'am.
Class, use the emoji. Raise your hand. Rishmika, Madhumita, Sindhu, Sanjay, Prajit, Rishmi, Arjun, Danya, Raja, Srijana, Nishant, Tanishka is there. All right, very good. Yeah, is this over, children?
Yes.
Yes,
All right.
ma'am.
Fine, children. Good. Continue writing, children. Sorry. Just a minute, children. Somebody's at the door. I'm just coming back. Yeah. Yes, somebody wanted to say something. Yes, who's that? Yes, Sindhu.
Is the second point a linear equation of polynomial, ma'am?
No, here I wrote linear polynomial. Here it is linear equation. I just corrected it. Yeah, linear equation. I always, while writing, yeah. Yes. Okay, children. So yeah, write down tell.
Completed, ma'am.
Yeah. So a linear equation in one variable x. A linear equation in one variable x has one and only one solution. We'll see that. We'll see what that means. Okay. So a linear equation in one variable x has one and only one solution. And the solution can be represented geometrically. The solution can be represented geometrically. So what is the geometric representation? This solution can be represented as a point on the number line. The solution, this one and only one solution, can be represented as a point on the number line. This is the geometrical representation. Algebraically, we can solve. We can algebraically solve and get the value of x. And that value of x can be represented geometrically as a point on the number line. We'll see that now. We'll see that now. Similarly, a linear equation in two variables x and y has infinitely many solutions. See, the first one has only one solution. A linear equation in one variable x has only one solution. But a linear equation in two variables x and y has infinitely many solutions. And a linear equation in two variables x and y is represented by a straight line in the Cartesian plane, the xy plane. The xy plane. Okay, so a linear equation in two variables x and y is represented by a straight line in the Cartesian plane. So in the first one variable is a point on the number line. Two variables is a straight line in the Cartesian plane. So we will see both of this now. Now, so since the geometric representation of a linear equation in two variables is a straight line, and we know that on a straight line there are infinitely many points. A line extends indefinitely on both the sides. A line extends indefinitely on both the sides. And we know that there are so many points on the line. Every point on the line will have an address. In the Cartesian plane, when you make the graph, you take one vertical and horizontal line. The horizontal line is the x-axis and the vertical line is the y-axis. So the plane on which the x-axis and the y-axis lie is called the Cartesian plane. The plane on which you have this x-axis and y-axis. X-axis is the horizontal line and y-axis is the vertical line. The plane on which the x-axis and the y-axis lie is called the Cartesian plane. Now on the Cartesian plane, you know that every point has an address like 1, 1, 2, 2, 1, 5. On the Cartesian plane, we know that every point has an address. So now when you take up the straight line, on the straight line, there are infinitely many points. And all these points will have an address, meaning they'll have some coordinates, xy coordinates, -1, -3, whatever, like that. Okay, every point on the straight line will have an address. So all these points are solutions to the linear equations. all the points on the straight line are solutions to the linear equation in two variables x and y. That is why we say a linear equation in two variables x and y has infinitely many solutions. Why it has infinitely many solutions? A linear equation in two variables x and y has infinitely many solutions. Why? Because its geometrical representation is a straight line. It's a straight line. And we know that on the straight line, there are infinitely many points. Every point on the straight line is a solution to the equation. There are many points. So all the points are solutions. And how many points are there? Infinitely many points. That is why a linear equation in two variables x and y has infinitely many solutions. We'll understand this better when we actually see the graph, the geometrical representation. Finish writing, children?
Yes, sir.
Yes, ma'am.
Yes, ma'am.
Now, let's just take an example to understand the earlier slide. Now, for example, say like 7x minus 11. Now, what is 7x minus 11, children? It's a linear polynomial in one variable x. And when you equate it to 0, it is a linear equation in one variable x. Now, let's solve this. Okay, in order to represent the solution on the number line, we need to solve this. I think once I complete it, and then I'll just make the whole thing, and then I'll explain. I think that will be better. So we'll solve this now. So 7x is equal to 11, x is equal to 11 by 7. All right, now this is the number line. It's a positive value, so I'm not taking much of the negative side. It's number line, children. It's a straight line. Okay, so this is say 0. I'm not showing the points. I'm not showing anything on this side because it's a positive value. I'm not showing anything on this side. Okay, so since it's 11 by 7, so we'll say this is 1 by 7, 2 by 7, 3 by 7, because it's 11 by 7, children. So after 0, I'm saying you have to make equal graduations. You know that. Equal graduations, okay? So 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, 7 by 7. This is 1. This is 1. After 0, this is 1. 7 by 7 is 1. Go on. 8 by 7, 9 by 7, 10 by 7, 11 by 7, 12 by 7. We got it. I'm just going up to 2. 13 by 7, 14 by 7. 14 by 7 is 2. This is 2. This is 1. This is 2. On the number line, 0, 1, and 2. 0, 1, and 2. Okay. So this is 11 by 7. This is 11 by 7. So this is x is equal to 11 by 7. You don't have to show anything on the negative side. If you want to show at the same distance, because from 0 to 1, you have this distance. So at the same distance here, you can say minus 1. At the same distance on the other side. See, you can see here 0 to 1. Look at the distance from 0 to 1. So at the same distance on the other side, you can just say minus 1. And since the denominator is 7, 11 by 7, the denominator is 7. So after 0, we start with 1 by 7, 2 by 7, 3 by 7. We go on like that. So 7 by 7 is 1 and 14 by 7 is 2. Then 21 by 7 will be 3 and so on. But we don't have to go so far because we already got 11 by 7 here. You don't have to make it so big. If I erase, the whole thing will go. See, you can put the arrow here and stop. You don't have to do so much. I can't erase only this part. The whole thing will go away. All of us got that?
Yes, ma'am.
Yeah, please complete this, children. You can just make a rough, a sketch in your book. Please take equal spacing. That's important. The spacing should be equal. The spacing should be equal. You can take like half a centimeter or whatever. The spacing should be equal. Tell me once all of you are done. Completed?
No, ma'am.
Okay. All right.
Completed, ma'am.
Completed, ma'am.
Fine, children. So now we need to understand why we say that linear equation and one variable x has only one solution. Okay, so now when you take up the left-hand side, 7x minus 11, and in place of x, when you use 11 by 7, when you use 11 by 7, the solution 11 by 7. Okay, so 7 and 7 gets cancelled, 11 minus 11, which is 0, which is the RHS. This is the LHS. In the LHS, 7x minus 11, in place of x, when you use 11 by 7, the value is 0. That is, it's equal to the RHS, 0. Now, there is no other value for x which can satisfy the equation. There is no other value for x. You give x some other value other than 11 by 7, the equation will not be satisfied. That is, you will not get 0. The LHS will not be equal to the RHS. RHS is 0. And when is the LHS 0? When is the value of the left-hand side 0? Only when x is 11 by 7. For any other value of x other than 11 by 7, the value of 7x minus 11 will not be 0. We can try that. You can give different values. Other than 11 by 7, you try some other value for x. You give some other value for x, you will not get 0. The RHS is 0. The equation is satisfied only if the LHS is equal to the RHS. So since only 11 by 7 satisfies this equation, we understand that a linear equation in one variable x has one and only one solution, because there is only one value for x which can satisfy the equation. Because there is only one value for x. Here, in this case, it is 11 by 7. X is equal to 11 by 7. So only this value of x can satisfy the equations 7x minus 11 is equal to 0. That's why we say a linear equation in one variable x has one and only one solution, because there is only one value of x which can satisfy the equation. And that one solution is represented by a point on the number line. That one solution, which is 11 by 7, is represented. This is the geometric representation of the solution. X is 11 by 7. So on the number line, find the point 11 by 7 and just circle it and write x is equal to 11 by 7. This is the geometric representation of the solution of this linear equation. 7x minus 11 is equal to 0. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, children, fine. So this explains the first part. Sorry, where am I? Oh, I cleared the screen, is it? Okay, so you have it in your book, no? We just wrote down, no? That a linear equation in one variable x has one and only one solution. We wrote that, right? This is the justification. Now the second part says a linear equation in two variables x and y has infinitely many solutions. And the equation, when you represent it geometrically, it is a straight line in the Cartesian plane. It's a straight line in the Cartesian plane. We'll see that now. We'll understand that now. So children, if this was supposing you saw, okay, if it was like 7x plus 11 is equal to 0, then you will get 7x is equal to minus 11, x is equal to minus 11 by 7. So on the negative side, you should show it. On this side, you must mark minus 1 by 7, minus 2 by 7, minus 3 by 7, minus 4 by 7, minus 5 by 7, minus 6 by 7, and this is minus 7 by 7, which is minus 1. Then go on like that, minus 7 by 7, which is minus 1. Then go on minus 8 by 7, minus 9 by 7. Go on like that till you get minus 11 by 7. So if it's negative on the left-hand side of 0, if it's positive on the right-hand side of 0. Same thing, what we did on the positive side, same thing on the other side you should do. Go on like that, minus 1 by 7, minus 2 by 7, minus 3 by 7. So minus 7 by 7 is minus 1. Minus 14 by 7 is minus 2. Now, yeah, I think I should tell you this very important thing before we move on to the next one. Very important. Right on, children. Now, every linear equation in one variable x can be treated as a linear equation in two variables x and y. Very important this is. A linear equation in one variable x can be treated as a linear equation in two variables x and y. The vice versa is not true. If it has two variables x and y, you cannot treat it as an equation in one variable x. The other way around is not true. If the equation has only one variable x, or it has only one variable y, if it has x or y, you can treat it. You can convert it to a linear equation in two variables x and y without making any changes to the equation. Without changing the value of the equation, I meant. Without changing the value of the equation, you can convert that to a linear equation in two variables x and y. In that case, it is a straight line in the Cartesian plane. When there are two variables x and y, representation, geometric representation is a straight line in the Cartesian plane. If there's only one variable x or y, it is a point on the number line. If it is a linear equation and only one variable x or y, then the geometric representation is a point on the number line. Only one variable, then it's a point on the number line. Two variables, then it's a straight line. Geometric representation is a straight line in the Cartesian plane. Then if it's a straight line in the Cartesian plane, it has infinitely many solutions. If there's only one variable x, there's only one solution also. And that solution can be represented as a point on the number line. If you treat that equation or you convert that equation to a linear equation in two variables x and y, then solutions, representation, everything will change. Everything will change. You have a linear equation in one variable x. Then when you solve it, you will get one solution. And how will you represent that solution? As a point on the number line. Finished. The same equation can be, without changing its value, its meaning, without changing its meaning or value, you can convert it to a linear equation in two variables x and y. The moment you have two variables x and y, it has infinitely many solutions. Two variables x and y, it has infinitely many solutions. And its geometric representation is also different. It is a straight line in the Cartesian plane. All of you got that?
Yes, ma'am.
Okay. Now, for example, we have 2x plus 3 is equal to 0. This is a linear equation and one variable x, and its solution is, on solving you get x is 2x is equal to minus 3, x is equal to minus 3 by 2. And you know how to represent minus 3 by 2 on the number line. Minus, no, so 0 is here. So this will be minus 1 by 2. This is minus 2 by 2. Minus 3 by, see, I start with 2 because the denominator is 2. So after 0, we say minus 1 by 2, minus 2 by 2, minus 3 by 2, minus 4 by 2, minus 5 by 2. We go on like that. Minus 2 by 2 is minus 1. Minus 4 by 2 is minus 2. And this is minus 3 by 2. This is minus 3 by 2. X is equal to minus 3 by 2. You can make a note of this, children. Please make a note of this.
Completed, ma'am.
Yeah. Now we are going to convert this equation, which has only one variable x, to an equation in two variables x and y. If you do that, its representation, the solutions will change and its representation also will change. Both will change. One variable x, only one solution, representation, point on the number line. Two variables x and y, many solutions. Representation is also different. It's a straight line in the Cartesian plane. Very simple, only these two cases you have. Finish writing this, children. Please do this representation also.
Completed,
ma'am. You can just do a freehand one. Need not be, like need not use a scale and, do the divisions and all that correctly. Do that in your exam. Yeah, so now the same thing, 2x plus 3, right? Plus 3 is equal to 0. Now the missing variable, to make it look like an equation in two variables x and y, the missing variable is y. So we'll introduce that. 2x plus 0y. 0y meaning 0 into y, 0y. Like 2 into x is 2x. 0 into y. So 0y plus 3 is equal to 0. Now when we introduce 0y, we don't change the value of the equation. 0y is nothing but 0. So it is still 2x plus 3 is equal to 0. Just that the absence of y is shown by introducing 0y. You can now see y there. Earlier you couldn't see the variable y. Now you can see the variable y. It's not 1y. If you add y, then you're changing the value of the equation. This we're not changing, 0y. So 0 it is. 0 into y is 0. So now this equation looks like an equation in two variables x and y. However, we have not changed the value of the given equation 2x plus 3 is equal to 0. You can see the presence of y without changing the meaning or the value of 2x plus 3 is equal to 0. Now, for this one, the table will look like this. Now, I'll explain the table. I don't know if we have time. No. Okay, I think 5 minutes. Yeah. Okay. Now, see your children. Now, what you should first do is you just solve this equation. Now, the given equation is 2x plus 3 is equal to 0, right? 2x plus 3 is equal to 0. Plus 3 is equal to 0. So on solving, you get 2x is equal to minus 3, x is equal to minus 3 by 2. Now, x is equal to minus 3 by 2. Okay, so in the xy table, x is always minus 3 by 2. X is always, see, what is the solution? I'll explain why. The solution is x is equal to minus 3 by 2. So x is always minus 3 by 2 for any value of y. Just get used to saying this. 2x plus 3 is equal to 0. When you solve, you get x is equal to minus 3 by 2. That's one part. But we are treating it as an equation on two variables x and y. So there should be x and there should be y. Make a table. Okay, x, y. And we're going to write three values for x and the corresponding three values for y. Now, what is it? We have x is equal to minus 3 by 2. That means x is always minus 3 by 2 for any value of y. For any value of y. You can take any value for y, like you can give y is 0, y is minus 3, y is plus 5, any value of y. Then on solving, you get x is equal to minus 3 by 2. It means x is always minus 3 by 2 for any value of y. Let me write that. X is always, for this situation, okay? X is always, not always. Here for 2x plus 3 is equal to 0. X is always minus 3 by 2 for any value of y, for any value of y. Now, is it correct? So let's see that. Now, let's take y as, we have taken y as minus 3, right? Just use it here, y as minus 3. Here, use y as minus 3. Let's see. See, the equation should be satisfied, right? The equation should be satisfied, right? So we'll check that. We'll check if the equation is satisfied. So now we're taking this 2x plus 0y is plus 3. This is the LHS. This is the left hand side. 2x plus 0y plus 3. This is the left hand side. 2x plus 0y plus 3 is the left hand side. Now let's 2 into, what should we get, children? When we put the values of x and y, what should you get? When you put the values for x and y, what value should you get? 0. We must get 0. So 2 into minus 3 by 2. What is the value of y? What is the value of y?
Minus 3, ma'am.
Minus 3. Yeah. Then what should I write?
Plus 3, ma'am.
Plus 3. Let's work this. 2 and 2 gets cancelled. Children. Minus 3.
Plus 0.
Plus 0, because 0 into minus 3 is 0. Plus 0. Plus 3. So it is 0, right? Which is the RHS. Are the values of x and y satisfying the equation? Yes. See, what is the LHS? This is the LHS. This is the RHS. RHS is 0. This is the left hand side. This is the right hand side. When you give the values for x and y in the left hand side and you work it, the answer should be 0. That means the values of x and y satisfy the equation. That means the values of x and y satisfy the equation. Let me just do the same thing again. We have taken, we've made the table of x and y. For some value of x, we have taken some value for y. Now we are trying to show that it satisfies these pairs of values, satisfy the equation. See, I'm taking up the LHS, which is 2x plus 0y plus 3. I'm using this value of x and y, this value of x and y. What is x? Minus 3 by 2. What is y? Minus 3 plus 3 as it is. Now 2 and 2 gets cancelled. Minus 3. This into minus 3. 0 into minus 3 is 0, not minus 3. 0 plus 3. Minus 3 plus 3 0, which is the RHS. So this pair, minus 3 by 2, minus 3 satisfies the equation. Now let's try the other one. Let's try the other one. The second pair. I think it's getting late for me. Yeah. Okay. LHS. What should I write, children? 2x plus 0y plus 3, right?
Yes, ma'am.
Yes,
Now
ma'am.
this is the second pair. This is the second pair. What is x?
Minus 3 by 2, ma'am.
What is the value of y?
0, ma'am.
0, ma'am.
Plus 3. Yeah, 2 gets cancelled. Minus 3 plus 0 plus 3, which is 0. RHS. So this pair of x and y also satisfy the equation. That means we have taken the correct values for x and y. Now the third pair. Now the third pair. So what is it? When x is equal to minus 3 by 2, you must say x is always minus 3 by 2 for any value of y. If you get y is equal to 3 by 2 or minus 3 by 2, that means y is always minus 3 by 2 for any value of x. We'll see that in the next class. So now the last one, last pair, 2x minus 0y plus 3 is the left-hand side. The last pair, minus 3 by 2 and 5. So 2 into x is minus 3 by 2 plus 0 into y is 5 plus 3. So 2 gets cancelled. Minus 3 plus 0 into 5 is 0 plus 3. Again, minus 3 plus 3 is 0, which is the RHS. So I told you can take any value for y, children, not that minus 3, 0 and 5. Take any value for y. When x is equal to minus 3 by 2, it means x is equal to minus 3 by 2 for x is always minus 3 by 2 for any value of y. All right, children, it's time for my next class. So that's it for today's session, children. We'll continue with this. I have something more to tell you regarding this. We'll continue. We'll see that in the next class. All right, children. That's it for today's session. Thank you so much. Can I leave the class?
Thank you, ma'am. Thank you, ma'am.
Thank you, children. Thank you.
ma'am.
Thank you, ma'am.
Thank you, children.